Hello friends, welcome you all. As part of this video, we will see Spark performance optimization technique. As we all know that during the development of any program, taking care of the performance is equally important. Spark job can be optimized by many techniques, so let's see those techniques one by one. First one is serialization. Serialization plays an important role in the performance of any distributed application. And we know that by default, Spark uses the Java serializer on the JVM platform. Instead of the Java serializer, Spark can also use another serializer called Cairo. So this Cairo serializer gives better performance as compared to my Java serializer. Cairo serializer is in compact binary format and offers approximately 10 times faster speed as compared to the Java serializer. So to set the Cairo serializer as part of my Spark job, we need to set a configuration property. So that property is org Apache Spark serializer.Cairo serializer. Next is API selection. So we know that Sparks come with the three type of APIs to work upon. So they are RDD, Dataframe and Dataset. RDD are used for the low level operation and they have less optimization techniques. Dataframe is the best choice in the most of the situation because Dataframe use the Catalyst optimizer which create a query plan and give a better performance. Dataframe is also generate low level garbage collection overhead. Third is Dataset. Datasets are highly type safe and they uses the encoder as part of their serialization. It also uses the tungsten for the serializer in the binary format. So it's all depend upon the user whether they can go for RDD, Dataframe or Dataset. Next is advanced variable. Spark come with two type of advanced variable. One is broadcast, second one is accumulator. So here we will see how this broadcasting will be helpful to optimize my Spark job. Broadcasting plays an important role while tuning your Spark job. Broadcast variable will make your small data set available on each node and that data will be treated as a locally for the process. Suppose if you have a situation where you have a one data set very small and another data set is quite huge and you want to perform the join operation between these two. In that case, we should go for the broadcast join so that this small data set can be fit into your broadcast variable. So here is the syntax given to use the broadcast variable, that is df1.join broadcast df2. Here we have a second data frame which is very small and we are keeping this data frame as a broadcast variable. Next is caching and the persist mechanism. Spark provides its own caching mechanism like persist and caching. This persist and cache mechanism will store the data set into the memory. Whenever there is a requirement where you have a small data set and that data set is being used multiple times in your program, so better to cache that data set. There are two mechanisms, cache and persist. So if I apply rdd.cache, it will store the data always in memory. If I apply rdd.persist, then we have a two option. Some part of data can be stored into the memory as well as on the disk. ByKey operation. As we know, During our transformation of the Spark, we have many ByKey operation. ByKey operation generate lot of shuffle. So shuffles are heavy operation because it consume lot of memory. So while coding in the Spark, a user should always try to avoid the any shuffle operation, because this shuffle operation will degrade the performance. If there is a high shuffling, then a user can get the error out of memory. In such case, to avoid that error, a user should increase the level of parallelism. There are few concepts also while coding of your program. Here one I have written, that is, instead of the group by, a user should go for the reduce by key, because group by key is creating lot of shuffling which hamper the performance, while reduce by key is not shuffle the data as much as compared to the group by key. That's why reduce by key is faster as compared to group by key. And whenever we go for any ByKey operation, user should partition the data correctly. Next is file format selection. Yes, so Spark comes with many file formats like CSV, JSON, XML, Parquet, ORC and Avro. There are many others. So Spark job can be optimized by choosing the Parquet file with snappy compression. So if I'm choosing my Spark job with the Parquet file along with the snappy compression, I'm getting the high performance and my analysis will be best in that case. Parquet file is native to the Spark, which carry the metadata along with its footer. As we know, Parquet file is native to Spark, which is into the binary format, and along with the data it also carry the footer. It's also carry the metadata as its footer. So whenever you create any Parquet file, so on the same directory along with the data file you will see .metadata file. Next is garbage collection tuning. So as we know, under the net our Spark job is running on the JVM platform. So JVM garbage collection can be a problematic when you have a large collection of unused object. So the first step in tuning of the garbage collection is to collect statics by the choosing a option in your Spark submit verbose. Generally, in an ideal situation, we should keep our garbage collection memory less than 10% of your heap memory. Next is level of parallelism. So in any distributed environment, parallelism plays a very important role while tuning your Spark job. We know whenever I submit my Spark job, it creates the DAG. So DAG will be consisting my stages and the task depend upon my partition. So every partition or task require a single core of my system for the processing. There are two ways to maintain the parallelism. One is repartition, second is Coalesce. Whenever you apply the repartitioning method, it gives you the equal number of partitions, but it will shuffle a lot. So it is not advisable to go for the repartition when you want to less shuffle the data. Another one is Coalesce. So Coalesce will generally reduce the number of partition and it's create the less shuffling of the data. There is a flag also given along with the Coalesce, yes or no. So based on your requirement, you can choose the flag whether you can put shuffle as yes or no. And thank you. So here we have seen few performance technique for the Spark job. There is one more important concept. While submitting our Spark job, we can configure with lot of parameters. Those are driver memory, number of executor memory, number of cores, and so on. So that Spark submit optimization on the memory level we will see in our next video. Thank you.